So now we're going to go back over quadrilaterals and triangles and help get ready for our quiz that's coming up. So to start with, we have quadrilaterals, which is any four-sided figure, and for this example we have a parallelogram. Remember, quadrilaterals break into either kites, trapezoids, or parallelograms, and then we can get more specific from there. So here I've got a parallelogram, so using those properties I'm going to answer these questions. So if EO is 8, so that's this side EO, it wants to know what GM is. Well, one property of parallelograms is that opposite sides are parallel and congruent, so GM must be 8. Then it says if TM is 7, so TM is this part right here, then ET, we want to find ET and EM. Well, another property is that their diagonals bisect each other, so it cuts them in half. So if TM is 7, ET must also be 7, which makes the entire diagonal 14. Alright, I'm going to go ahead and erase what we've got on here, make room for the next problem. It says if OG is 21, so OG is this entire diagonal, is 21, then GT, which is half of the diagonal because it's bisected, must be 10.5, or 21 over 2. Alright, and then if the measure of angle GMO, so if this whole angle down here is 122, I want to know what angle EGM is. So EGM is this angle over here, and these are back to back, so they're consecutive. And consecutive angles in a parallelogram are supplementary, so 180 minus 122 is 58. Alright, I'm going to erase again. And the last question says if the measure of angle 6 down here is 25, and the measure of angle 5 is 78, I want to know what the measure of GEO is, so this whole angle up here. Well, again, E and M, they're opposite each other. With parallelogram, opposite angles are congruent. So 75 plus 28 gives us 103. So that means angle E must also be 103. All right, another quadrilateral is an isosceles trapezoid, which is a specific kind of trapezoid, and it's a symmetrical one. All right, and this one says that if the measure of angle 1 down here is 73, we want to know what angle 2 is. Well, angle 1 and angle 2 are consecutive in my big trapezoid, and so that means that they are supplementary. So then we have 180 minus 73, which is 107. Then angle 3, this angle 2 is 107. Angle 3 and angle 2 are congruent, so that means angle 3 is also 107. And then angle 4 and angle 1 are congruent, so angle 4 is 73. Alright, then we have OP is 12, so that's the top side up here. HE is 17. We want to find what FL is. Now this FL, that's the midsegment, because of these dashes, it tells me it connects the midpoint. So this is our midsegment, and to find the midsegment, we find the average of our two bases. So we would do 17 and 12 divided by 2. Well, 17 plus 12 is 29, and 29 over 2 we can't simplify. So you can say 29 over 2 or 14.5. Okay, then it changed it up on us a little bit, so I'm going to erase what we have. And says now OP is 11, and FL is 18. So we want to know what HE is. Well, this 18 is right in the middle of 11 to HE, right? So one option is to say from 11 to 18 we add 7. So from 18 to HE we add 7, which would give us 25. Or you could write that equation and say 11 plus my other base over here divided by 2 has to give me 18. So then we times it by 2. So 11 plus B equals 36. And then 36 minus 11 is 25. Right, but the easier route is just to know that midsegment is right in the middle of the two bases. Right, then we looked at a triangle midsegment. So midsegment connects midpoint to midpoint. Right, and the couple properties about it is that it's parallel to the opposite side and half the length. So to find x and z in this case, the x's go together and the z's go together, and it's telling us that these are midsegments. Right, so then that means that it takes 2 x's to get this 5x minus 18. So I'm going to say 2x equals 5x minus 18. Subtract my 5x, so negative 3x equals negative 18. Divide by negative 3, so x equals 6. Right, for y, it takes 2 of the z plus 8 to get 1 of the 3z minus 10. 2 times z plus 8 is 2z plus 16. Alright, if I subtract the 2z over, I get z, and then add my 10, and I get 26. So 26 is z. Right, after we did our midsegment, we looked at our different types of centers. One center that we don't have in this video because we don't really have math problems with it is the orthocenter. And the orthocenter connects or intersects all of the altitudes or the height of the triangle. All right, so that's our orthocenter. Here we're going to look at the centroid, and our centroid connects vertex to midpoint. All right, so this is my centroid here, this G. And then we know that the centroid is 2/3 of the way from vertex to midpoint. All right, so in this case, we know that BF is 9. So BF, this whole thing here, is 9. And AE, this thing, is 4. All right, so first I want to find BG. Well, I know that my way of remembering is to say that the whole thing is 3x, the long side is 2x, short side is x. So for this case, the whole thing is 9, so 9 divided by 3 is 3. So my short side's 3, and then 2 of the short sides is 6. So BG is 6, and then GF is 3. Okay, I know that median connects vertex to midpoint, so that means that these two pieces are the same. So if AE is 4, that means EB is also 4, and that whole side has to be 8. All right, then we have the end center, and the end center is where the angle bisectors intersect. And what's special about that is that it's the same distance from all of the sides of the triangle. Okay, so it tells us here that G is the end center, and it says EG is 8. So this part's 8. The measure of angle GAD, so GAD, this angle in here, is 50. I want to find GD. So if EG is 8, that means GF and GD must also be 8 because they're all the same distance. And then I want to find the measure of EAG. Well, an angle bisector cuts the angle in half, so both of these are the same. So EAG must also be 50 degrees. And then we have the circumcenter. And the circumcenter is where the perpendicular bisectors intersect. And what's special about it is that it's the same distance from all the vertices. So all the corners are the same distance from the circumcenter. So in this case, I want to find x and y. So if I look at x, I know that it's a perpendicular bisector. So that means it comes to the midpoint of each side. So that means that if AE is 21, it's the same as 3 times x minus 3, or x plus 3. Right? Because this has got to be the midpoint, so these two are halves and they have to be equal. Well, 3 times x plus 3 is 3x plus 9. Move the 9 over. 21 minus 9 is 12. Divide by 3. X equals 4. To find y, we've got this 4y minus 3 that's coming from the circumcenter to k. So that distance has to be the same as from k or n to r and n to a. Well, I know n to a is 9. So that means 9 is the same as 4y minus 3. Add the 3 over, so I get 12 equals 4y. Divide by 4, and we get y equals 3.